Now let us see how to plot, polar plot. It can be called Nyquist plot also because it is part of Nyquist plot. That's why polar plot sometimes interchangeably called as Nyquist plot. Now we will see how to draw the Nyquist plot, polar plot. G of j omega, that is sinusoidal transfer function, can be in Bode plot. What we did is we find the magnitude of j of omega in polar form. Here also we are doing in polar form, but we are not plotting against logarithmic frequency. Instead, we are taking magnitude and phase. We are plotting between magnitude and phase in polar chart. That is called the polar plot. It can be used to study about stability analysis. If you consider RL circuit, if you write KVL for the RL circuit, we will get the input voltage is equal to L dIdt plus Ri, that is the KVL. If you assume the voltage across resistance output that V0 equal to Ri of t. For that, if you obtain the transfer function, it is nothing but a first order transfer function V0 by Va equal to 1 by tau s plus 1, where tau equal to L by R. If you convert this into sinusoidal transfer function, replace s by j omega. For that, we will get 1 by 1 plus j tau omega. As omega varies from 0 to infinity, we will get phase as well as magnitude. If you plot in the polar chart, that is called polar plot. We will see here omega equal to 0. If we substitute omega equal to 0, in that 1 by 1 plus j omega tau. Magnitude is 1 by square root of 1 plus omega square t square. Omega square t square. If we substitute omega equal to 0, then it becomes 1. The magnitude becomes 1. Angle tan inverse of 4 degrees. Here the magnitude equal to 1 by square root of 1 plus omega square t square, and phase angle equal to tan inverse of omega tau for first order system. If we substitute omega equal to 0, it becomes 1. When omega equal to 0 here, it becomes angle is 0. Therefore, the first coordinate is 0, 1. 0, magnitude is 1, angle is 0. That's why this is the point. Final point, if you see, previous slide, if we substitute omega equal to infinity, then it becomes 0. The magnitude becomes 0, and the angle tan inverse of infinity equal to minus 90. Therefore, this ends at 0, that is magnitude is 0. At what angle it approaches the origin is at minus 90 degree. If you see in between here, you will get minus 45. When omega equal to 1 by tau, you will get minus 45. Minus 45 is about this. So, for various values of omega, if you plot, it will be a semicircle like this. This is a polar plot of first order system. I can say that the polar plot always starts at positive real axis. For a type 0 system, the polar plot starts at positive real axis and end along negative real axis. Imaginary axis. Along at an angle minus 90 degree. There is no positive axis, negative real axis, right? Negative axis, imaginary axis, not like that. It is a polar chart. So it ends at an angle minus 90 degree. It ends at an angle minus 90 degree. It starts at 1, angle 0 and ends at 0, minus 90. So it approaches the origin at an angle minus 90. For when omega equal to 1 by tau, it is minus 45. So the plot is like semicircle, starts from 1 angle 0 to 0 angle minus 90. This is polar plot for first order system. So, always to draw the polar plot, first we have to find the starting point and end point and the intermediate points. If we find that, we can draw the polar plot. Next, if it is a type 0 second order system, a type 0 means there is no S. there is no S. If it is type 0 second order system, the magnitude is k divided by square root of 1 plus omega square d1 square, square root of 1 plus omega square d square. When omega equal to 0, again it is k angle 0, k angle 0, because tan inverse of substitute omega equal to 0, 0 means angle also 0. It starts at k angle 0, where it ends, substitute omega equal to infinity, it becomes 0. So end at 0, but at what angle? Here if you substitute omega equal to infinity, here also omega equal to infinity, minus 90 at 180. So go to next, so starts at k angle 0, end at 0 at angle 180. It approaches the origin at 180 degree. So for type 0 system, first order, it starts at k0 or 10 and end at minus 90 degree at origin. If it is type 0 but second order system, starts at k0, end at 0 angle minus 180. If it is type 0 third order system, it will start at k0 but end at plus 90 or minus 270. It ends at minus 270, like that. So, if it is type 0 system, it will always starts at positive real axis, positive real axis. That way we can tell. Then next. Another thing, while drawing polar plot, it is very important to find where it intersects the real axis and imaginary axis. That is very important. Otherwise, it is very difficult to select the coordinates. Omega, we have to select some coordinates to draw the polar plot. How to select it? The range is from 0 to infinity. How to select the coordinates? It is very difficult. That's why we have to find where it intersects the negative real axis or positive real axis. Real axis where it intersects. In the imaginary axis where it intersects, we have to find. If it doesn't intersect negative real axis, imaginary axis, we have to find only where it intersects the real axis. That alone is sufficient. But anyhow, these 2 points we have to find these 2 points. Then only we can draw the polar plot. For that, what we have to do? We have to this is a complex number. This is complex number. So we have to separate the real part and imaginary part. For that, we have to multiply this by complex conjugate of denominator with numerator and denominator. Here, take complex conjugate of this 1 minus j omega tau 1, 1 minus j omega tau 2, 1 minus j omega tau 3. You multiply the numerator and denominator by complex conjugate. Denominator becomes pure real. Denominator becomes pure real. 1 plus omega square t1 square, like that it came. So the numerator becomes both real and complex. Separate real part and this imaginary part. Equate that. Here, what is the imaginary part? Here it intersects the real axis. That's why imaginary part is 0. That's why equate the imaginary part 0 and find the value of omega. That particular value of omega, it intersects the real axis. Similarly, equate the imaginary part to 0. Imaginary part here the imaginary part is 0. Here equate the real part to 0. You will get where it intersects the imaginary part. By using that, we can find omega x and omega y. Substitute these values in the magnitude, you will get where it intersects the real axis and the imaginary. That is very important. Because if you know that, then only we can select the omega value in and around that intersect point. So to draw this, we have to select omega x in and around this value. Suppose omega x equal to 0.9 means we have to select 0.5, 0.4, this side 1.1, 1.1 like that. Here suppose here omega equal to some say 0.3 means we have to select 0.2 to 0.5 like that. Then only we can select the points to draw the polar plot. If there is no denominator factor, then it is convenient to draw. When we have a thumb rule to draw this rough polar plot for all transfer functions, if numerator transfer function is absent, then only we can draw that. This is type 1 system. This is type 1 system. Because S is in the denominator, that's why it is a type 1 system. In the type 1 system, if you substitute omega equal to 0, it becomes infinity. So it starts at infinity. If you substitute omega equal to 0, it starts at infinity at an angle minus 90. So it is coming from minus 90, infinity angle minus 90. It is coming from there and end at 0. Always the denominator degree is higher, that's why if you substitute omega equal to infinity, definitely it becomes 0, therefore magnitude is 0, but phase angle, put this infinity here, minus 270. So it approaches the origin at an angle minus 270. What next slide? So it is coming from, it should be this way. It is coming from minus 90 and approaches the origin at an angle. As omega approaches infinity, it approaches the origin at an angle minus 270. That's all. So this is a rough polar plot for a type 1 third order system. Type 1 third order system. So type 0 means starts here. Type 1 means starts here. Definitely type 2 means it will start here. Type 3 means starts here. So the starting point is based on the type number. Ending point is, if it is first order, ends here. Second order, ends here. Third order, here this is third order. Third order ends here. Fourth order ends here, like that. So if the numerator polynomial is absent, means by using this thumb rule we can draw the rough diagram. But only thing is you have to find where it intersects the real axis. For that, take the transfer function, multiply the numerator denominator by complex conjugate, and separate real part and imaginary part. Here imaginary part is 0, equate the imaginary part is 0. You will get where it intersects the real axis. For that, you will get omega value only. Substitute that omega value in the transfer function. You will get the magnitude at which it intersects the real axis. So that suppose I want to draw this polar plot, means it comes from infinity and ends at 0, but where it intersects the real axis I do not know. In the table I have to fill. First value I can fill when omega equal to 0. Similarly, when omega equal to infinity, final value also I can fill. Intermediate values how to select. For that, find omega x. This side you select some 3 values. Right side you select some 3 values. So that here you will get some 3 points. Here also you get 3 points. You can draw that. That's why the point of intersection is very, very important while drawing polar plot. Here all type 0 system. Type 0 system first order starts here and ends here. Type 0 second order. Type 0 third order. Type 0 fourth order. So this way it will end. Fifth order. Type 0 fifth order. So this way the polar plot will appear. If it is type 1 system, always it comes from infinity at an angle minus 90, and if it is type 1 second order, type 1 third order, type 1 fourth order, like that. Here this is different systems. Here what is this? 1 by s. So type 1 first order. So it ends at minus 90, starts at minus 90. That's why it is on the imaginary axis. Here it is type 1 but second order. This is type 2, 1 by s square. Type 2, that's why it starts here. But third order, that's why it ends here. And this is s over 3, type 3, that's why it comes over here. And at the fourth order, that's why it ends here. This is s power 4, type 4, that's why it is coming from. And r raised to fifth order, that's why it ends here. So we can draw the rough diagram. That is very, very important for Nyquist plot, Nyquist stability analysis. Because Nyquist stability analysis, you need not draw any graph. The only thing is you have to draw the rough diagram. For this, we should remember this rough plots. Then only we can draw the Nyquist rough diagram. Multiply the numerator and denominator by complex conjugate. Denominator becomes pure real. Then separate the real part and the imaginary part. If you equate the imaginary part to 0, you will get where it point of intercept at the x-axis you will get, real axis you will get. Similarly, if you equate this, you will get point of intercept with what value of omega it will intercept the imaginary axis you will get. That way I got yx equal to function of time constant, omega y equal to omega x equal to function of time constant, omega y equal to function of some time constant I got. This way we have to find the coordinates, otherwise it is very difficult to find the coordinates. So to draw the polar plot, first we have to, if there is no polynomial in the numerator, we have to draw the rough curve. Then where it intersects the x-axis, real axis and the imaginary axis, we have to find by this method. Then we have to prepare a table and draw. That's all. Sketch the polar plot for the system whose open loop transfer function is given as 1 by s multiplied by s plus 1 whole square. Determine the gain margin and base margin. Here 1 by s multiplied by s plus 1 whole square, and the sinusoidal transfer function is j omega plus 1 whole square, Here also it is whole square. If you write modulus value, you will get omega multiplied by 1 plus omega square. Omega square, because of the square is getting cancelled. The angle is minus 90 2 times because of the square 2 times tan inverse of omega. That's all. So if you substitute omega equal to 0, definitely it starts from infinity at an angle. If you substitute this equal to 0 means minus 90. It is what is that? Dipole system. That's why it starts from minus 90. And where it ends, take the infinity, substitute infinity, it becomes 0 magnitude. If you substitute infinity here, 90 multiplied by 180 plus 90, 270. It ends at minus 270. That's all. We got both the starting point and ending point. How to select the intermediate point? For that, we have to take this, multiply the complex conjugate, the numerator and denominator, equate the real part and imaginary part to 0, find the intercept with the real axis and imaginary axis. And here, already we know that the omega x equal to 0.5. That way, it is found that omega x is 0.5. So that's why it is on both sides of values are selected. Both sides of values are selected. To find gain margin and phase margin, this point of intercept with the real axis is very, very important, because we have to find the magnitude of A to find gain margin. Gain margin equal to 20 log 1 by A. To find the intercept with the real axis, where it intercepts is important. That's why this 0.5 omega x you have to find by equating the imaginary part to 0. That is very important. That's all. Once we have drawn, we can find the gain margin, phase margin. So where it intercepts the real axis, for that take the magnitude and the gain margin equal to 20 log 1 by A. That's all. Phase margin, draw the unit circle, where it touches the unit circle. At that point, what is the magnitude of that system? 180 plus that angle. 180 plus that angle, you will get phase margin. That's sketch the polar plot of the unity feedback system with an open loop transfer function. Also find the frequency at which angle of G of them is equal to 1. Frequency at which, it means what? Gain crossover frequency. He didn't mention the gain crossover frequency. He wants to find gain crossover frequency. Gain crossover frequency means where it intersects the unit circle. At that point, what is the frequency he is asking? How to find that? To find the frequency at modulus of G of m equal to 1, we note that the polar plot cuts the unity circle at 170 degree. That he can easily find at 170 degree. Take that angle equation, angle of G of m equal to minus 90. This is continuation of previous one. So minus 90 minus 2 tan inverse of omega, that is equal to 170. From the plot we can write the magnitude is minus 170. Minus 2 170. If we substitute that, from that we can find omega. That is the gain crossover frequency. So this is the idea how to find omega x. Directly we cannot find omega from the plot. That's why either we have to use modulus of G of j omega to find omega, or we have to use the angle of G of j omega. Here, angle of G, if modulus of G of j omega equal to 1 means it is better to use the angle. That's why we use the angle to find omega. So the angle is 0.84 radians per second.